All right, we are on to a new chapter. We've just got a couple of weeks left, and we are going to go ahead and get this started now. It's a pretty short chapter. It's always been a short chapter. It's just going to feel even shorter because we're doing it through e-learning. So we're going to talk about circles and what some special properties are. We've seen them a little bit throughout the year, but we are going to kind of delve deep into them, starting with equations. So some of you who are in Algebra 2 have actually already seen this, but it's a good review for you, and it's good for everybody else who hasn't had Algebra 2 yet, so that way you know what's coming. So let's go ahead and get started, and let's see what we can do with circles. Oops. Oh, okay. I didn't know I could make that picture bigger. Anyways, in the graph at the right is a circle with a radius of 10 units. So remember, a circle, it has its central point, and we can see here it extends outward all the way to 10. So we've got our radius of 10. And we can see that it does that not just horizontally, so it could extend to the right 10 units, it could extend up 10 units, it could extend left 10 units, it could extend down. Okay, so all of these distances, and that's true if I was to go diagonally, it would also extend 10 units. So what do all of the points in this circle, all of these points on the edge, all of these little points, if I could draw those accurately, what do they all have in common? Well, ooh, that's too big. They are all, let's see if I can get this thing to go where I want it to go. Let's see if I can type. They are all the same distance from 0, 0, from the center, which is 0, 0. Okay, so kind of how that works. Let's see here. I'm just going to make that red so you guys can see that better. Okay, so it says find all of the points on the circle where x is equal to 6. So this is some good function evaluation. So when x is 6, that means we went 6 units out. So here I'm at x is 6. That's not on the circle, that's on the x-axis. So if I was to go up, here is a point, 6, 8 on the circle, that x has a value of 6. Are there any other points on the circle? Well, if I went out and down, I could be here, which is the point 6, negative 8. So x is 6 and y is either positive 8 or negative 8. So it says use a right triangle to justify that we know this is in fact part of the circle, that point is the point we're talking about. Well, we said that all of the points on the circle are 10 units from 0. And we can see here that we went out 6 units. Since we went directly up, we made a right angle, so now we have to figure out, just to verify, is that in fact going to be a height of 8? Or is 6 squared plus 8 squared equal to 10 squared? So 6 squared is 36, 8 squared is 64, and 10 squared is 100. So is 36 plus 64 equal to 100? Yep. What if we went the other direction? What if we went out 6 and down to negative 8? What if we went downward? If we still have a radius of 10, does 6 squared plus, and I'm going to put this in parentheses because I'm saying the whole thing, negative 8 squared equal 10 squared? So does 36 plus, what happens when you square a negative? Negative 8 times negative 8 is positive 64. Does it in fact still equal 100? And yes, it in fact does. So we're just proving that the Pythagorean theorem kind of helps us to see that the circle still extends or has that radius of 10 all the way around. So then it says here, what if x is equal to negative 3? What points would what would the y value be? So if I went down out negative 3, backwards negative 3, and I went upward, we can see it's kind of in the middle. We can't exactly tell what value. That's not a very straight triangle, but that's okay. We can't exactly tell what value the y equals. We can't tell that it's positive 8 or negative 8 or positive 9 or negative 9. It kind of looks like it's in between 9 and 10. It kind of looks like it's about 9.5. So how could we use what we've just learned to help us find that y value? Well, we could use our Pythagorean theorem. If I did negative 3 squared plus our y value squared, that should equal a radius of 10 units. So negative 3 squared is 9, plus y squared equals 100. We would subtract 9 from both sides, leaving us with y squared equals 91, and then we would square root. And the square root of 91, I did this calculation earlier, is about 9.54. So that could be a possible, and it appears to be pretty close, negative 3 and then 9.54. And then if we were to look, if I went out negative 3 and downward, would that also give me about negative 9.54? And yeah, it sure would. So that would be another possible value. Two locations where we know the x value, we're trying to come up with the y value, and that's because of how the circle expands or extends. So Maya picked a random point on the circle and labeled it xy, but she doesn't have a value of x or a value of y. So how could we use an equation to help us relate x, y, and 10, the radius, based on this diagram, based on this information that we see? So if we have an x and we have a y and we know the radius is 10, how could we use that to help us find any point on the circle? Well, just like we've been doing, we could use our Pythagorean theorem. So it would look something like that, or we could even simplify it to say x squared plus y squared equals 100. So a circle really just comes from our Pythagorean theorem. So then the question here becomes, does the equation work for any point on the circle? So we said we knew for a fact that 10, 0 was part of the circle. So if this is my x and this is my y, does 10 squared plus 0 squared in fact equal 100? And yeah, sure, because 0 squared is nothing, 10 squared is 100, so yes, it works. What if it was 0, 10? Well, we just plug in 0 squared plus 10 squared equals 100, and yep, sure enough, that works. What if we had negative 8, negative 6? Well, let's check. So if I did negative 8 squared plus negative 6 squared, does that equal 100? And negative 8 squared is positive 64 because a negative times a negative is a positive. And negative 6 squared then would also be positive 36. And does 64 plus 36 equal 100? Yes. And that's because when you square your negative, you're always going to get a positive. So that's the basic idea of a circle. So let's expand this idea even more. In our previous problem, we wrote an equation that had a radius of 10 and a center at 0, 0. So what if instead the radius was 4 units long? How would the equation look if it was centered at 0, 0 and had a radius of 4? Well, we would have kind of our picture like so, with our radius being 4 units. And we know that no matter where we drew this, we would have 4 for our radius. So we could say that our x squared plus our y squared would equal 4 squared. Or even more simply, x squared plus y squared would equal 16. So evaluating a little bit of what that point is, that the exponent. So then here we're getting into even more of a generic equation. What if it was centered at 0, 0 and it had a radius of r? So meaning we don't actually know how big the radius is. It's not 4, it's not 10, it could be 12, it could be 5, it could be whatever. Well, then we would just say x squared plus y squared equals r squared. And so then that brings us to our next idea. Can we sketch the graph of x squared plus y squared equals 36? So if it's already been kind of expanded or genericized, I don't know if you can do that or not, we can tell that because it's just x squared plus y squared that we have a center at 0, 0, just like all of the other ones we've been looking at. And now it says here that it's 36. Well, obviously we don't have 36 units on this graph, but this 36 is the radius on the equation. So if r squared is 36, well then what's just the radius? Well, the radius must be the square root of 36, which is just 6. So could we center a circle at 0, 0 and draw it with a radius of 6 without using a table? Sure thing. We could go out 6 to the right and plot a point. I could go up 6 units and plot a point. I could go left 6 units and plot a point. I could go down 6 units and plot a point. And then I could just make my graph as accurate as possible as you can, drawing a circle. Considering I'm doing this on the computer, that's not too terrible. So there is a circle that has a center at 0, 0 with a radius of 6. So approximately something like that. So what would we think the graph would look like if we were drawing it, if it was x squared plus y squared equals 0? Oops, let's try that again. So what would it look like? Well, it would probably be a point at 0, 0 without a radius, because the radius is 0. So in other words, just a single point, because there's no radius. And that's really all that is. So what does it look like? It looks kind of like that. Let's do purple. Let's do red. There we go. Red just jumps out of the screen a little bit better. Okay, so here's the next part, the next little tricky bit. What if the center of the circle is not at 0, 0? How does that happen? How does that look? So let's see if I can draw this. We're going to say in the graph, construct a circle with a center at 3, 1. So we're going to start here. There's our center. And it's going to have a radius of 5. So I'm going to go 5 to the right. 1, 2, 3, 4, 5. So I'd be at 8, 1. I could go up 5. 1, 2, 3, 4, 5. So I'd be at 3, 6. 1, 2, 3, 4, 5. So I'd be at negative 2, 1. Or I could go down 1, 2, 3, 4, 5. And there would be my point. Let me see here. I'm going to see if I can cheat a little bit and let my, haha, I am cheating. I'm a cheater. There's my graph there. I'm going to draw that back in. I totally cheated and used the computer program to help me find my circle so that it was something I wasn't going to be able to erase. Okay, so it says plot point P at random and sketch a triangle like the one shown. So sketch a right triangle. So they're showing us here. Oh no. Okay, let's try that again. They're showing us here. We've got this random point P drawn in, and we've got our right triangle AB. Oops. So let's see here. If I was to draw, let's see here, something like this, maybe we can't really tell exactly what those values are, but here's our X and here's our Y, and point P is X comma Y. So actually this isn't really X, Y. This is saying like AB. Oops, let me try that again. Errors. So this is like A, B, and then of course our hypotenuse C. Okay, so what expression could represent the length of AB? And so if we look over here, we can see AB is the bottom of the triangle. So it looks like that's about 3 units long. But if we were actually plotting point P is not the point 3 comma something, it's 6 comma something. So how do I evaluate or figure that out? So what I could do is I need to subtract the X value from the center. So that was our capital point A. So that X value was, so I could say it's like X minus 3. And then if I was looking for the length of PB, that's this vertical height here. So it looks like it's at about 5, but our Y value looked like it's at about 5, but I didn't go 5 units up. I went 1, 2, 3, 4. So how am I getting 4 units as the height of the triangle, but 5 as the value in the graph? Well, I needed to subtract the y value from the center. So this would be more like y minus 1. So my y value for my point minus the y value from my center, y minus 1, right, because y value in the center was 1, that's what kind of creates that equation for us. So this is kind of an abstract. The more we would get into it, the easier it gets, but we're just trying to get to a generic formula here. So really what we're saying is instead of x squared plus y squared equals our radius, our 5 squared, we could say our x value is actually x minus 3 because I had to take away the center, plus our y value, which is actually y minus 1 because I shifted the graph, and it equals our radius squared, which was 5 squared or 25. And so that's what kind of gives us that generic equation. And if you look here, boom, there's our generic equation for the circle. HK is the center of the circle, R is the radius. So we're going to subtract the center values and we're going to square our radius. So let's do just a couple of quick examples here. If I was to write the equation of a circle, if it's centered at 2, 7 with a radius of 8, well then what we would do is we would say x minus our x value from the circle, from the center, so x minus 2, plus, and then we would say y minus our y value from the center, which would be 7, equals our radius squared, so I would need to do 8 squared, which is 64. And that's all that really is to it. So just this generic equation that we come up with. What about step 2 says find the equation for the circle shown in the graph. So we can see here that its center is at 3, -5, and we need to know what the radius is. So if I was looking at this graph, boom, 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 here's the radius, and I need to know what that value is. So it's going out 1, 2, 3, 4 to the right, and it's going up 1, 2. So I would need to do 4 squared plus 2 squared to figure out my radius squared. So that would be 16 plus 4, or 20, equals my radius squared, or my radius is the square root of 20. I'm just going to leave it like that for now because there's a cool shortcut. Since we're looking for the equation of the circle, I'm going to say x minus my x value, 3, plus y minus my y value, which is -5, and we'll come back to that in just a second, equals my radius squared, so square root of 20 squared. So really, this is saying x minus 3 squared plus, when I subtract a negative, I get a positive. And when I square a square root, the square and the square root go away, so I end up with just 20. And so there would be my formal equation for that circle. And then I've got another one here. What if I said the circle for which 6, 0 and -6, 0 are endpoints of a diameter. So if 6, 0 is one endpoint of the diameter and -6, 0 is the other endpoint of the diameter, well, where does the center of the circle have to be? Well, the center is halfway from one end of the diameter to the other, so our center must be at 0, 0. Yep. Try again. And what's the radius of this circle going to be? Well, if the circle is centered at 0, 0 and has a radius or has a diameter from -6 to +6, that means the radius must go from 0. Oops, that's not it. Try that again. The radius must go from 0 to 6. So our radius is 6. So we could say that our center, we could say x minus 0 squared plus y minus 0 squared equals 6 squared. Or to shortcut this, we could just say it's x squared plus y squared equals 36. And there would be our equation. Not too terrible. Last one. What is the circle shown in the graph? What is the equation for this circle? Well, for this, I need to know where is my center. So what I'm going to do is I'm going to draw in a couple of diameters so that they intersect, so that they cross. So what is this coordinate right here? What's that central point? So let's see here. It looks like I'm at -3 and then down at -5. So there's my center. And I need to know then what's my radius. And luckily I can 1, 2, 3, 4, 5 count my radius, which is just 5 units. And so now I just need to plug that information into my equation, and that's going to give me x, I would say minus -3, but that's going to turn that into a +3. And I would say y minus -5, but that's going to turn it into a +5. And I'm going to equal my radius squared, which would just be 25. And that's really all it is. So most of your homework is really just, here's my couple of pictures, plug it in, find your equation, but we wanted to make sure that you understood that this is all coming from the Pythagorean theorem, and that's really what a circle is all about. It's really, circles are actually just triangles rotated around a central point, which is pretty exciting to think about. Very abstract when you get into that kind of ideology of it, but that's the basics of it, and what we can do with them is plug them into our Pythagorean theorem. As always, if you have any questions, please feel free to contact me and I can help you out. Alrighty, good luck.